property says that, you can go ahead and bring your regression equation in its deviation form. So what we did till now is to bring our beta 2 hat in the deviation form. But we can also kind of go ahead and write the regression equation in the deviation form. Let's try and do that. So yi is equal to beta 1 hat plus beta 2 hat xi plus ui hat. Let's get this in the deviation form. So deviation form would be the following. Step 1. Take summation on both sides. If I take sum on both sides, I will get sum of yi is equal to sum of beta 1 hat plus beta 2 hat xi plus ui hat. This would be summation beta 1 hat plus beta 2 hat summation xi plus summation ui hat. I know that, this part right here is 0, right? The sum of the errors is 0. So this will be n beta 1 hat plus beta 2 hat summation xi is equal to summation yi. So I have, and I can kind of go ahead and take this forward, divide throughout by n, and I will get y bar is equal to beta 1 hat plus beta 2 hat x bar. I will name this as equation 2. And I will take this as equation 1. I'm going to subtract equation 2 from 1. So equation 1 that I have is this: yi is equal to beta 1 hat plus beta 2 hat xi plus ui hat. Equation 2 is y bar is equal to beta 1 hat plus beta 2 hat x bar. Let's subtract this. What will I get? I will get yi minus y bar is equal to beta 2 hat. This gets cancelled. Xi minus x bar plus, this is nothing but 0, ui hat. Okay. Now, can I rewrite this as small yi, because this is in deviation form, is equal to beta 2 hat small xi plus ui hat? So this is called the deviation form. Now I know that if I write deviation form of entire equation as this, then this part only is the deviation form of yi hat, which is nothing but yi hat minus yi hat bar, right? So I can also write that in deviation form. If I talk about the regression line, because on line there is no error, I have yi hat, small yi hat is equal to beta 2 hat xi, right? So this is my deviation form of yi hat, and this is my deviation form of yi. This is the fourth property of regression line. The next property of regression line is the following. The residuals are uncorrelated with predicted yi. I'll take it as capital yi. You can take it as small yi or capital yi. Proof holds for both. Okay. So by predicted yi, I mean actually yi hat, capital or small. Either should be fine. You can, if you prove the one, the other will automatically hold true. Okay. Now, in order to prove that there is no correlation between two things, ideally what we have to prove is the following. So if I have to say that there is no correlation between x and y, I should be able to prove that summation x minus x bar, y minus y bar is 0. Okay. If I'm able to prove this, then automatically there is no correlation between x and y. So similarly, if I have to prove that there is no correlation between, our yi hat and ui, ideally what I have to prove is summation yi hat minus yi hat bar, ui hat minus ui hat bar is 0. This is what I have to prove. Now I know that the mean of the error term is 0. So I can directly write 0 here. So it would be summation small yi hat ui hat is equal to 0. This is what I have to prove. Now let's start with the proof. So to prove this, what I should be doing is, let's see what is yi hat. Yi hat can be written as beta 2 hat xi. And how do I know this? I know this from our last proof. In deviation form, yi hat is beta 2 hat into xi. So I'm using the deviation form of yi hat and I'm writing that as beta 2 hat into xi. What will be yi hat ui hat? That would be beta 2 hat xi ui hat. This will be beta 2 hat xi into yi minus beta 2 hat xi. What am I doing here? Go back to the deviation form. From this deviation form that you just found out, derive ui hat. What will be ui hat? Ui hat will be yi minus beta 2 hat xi. This will be ui hat. So I'm just writing this down. Instead of ui hat, I am writing yi minus beta 2 hat xi, making everything in the deviation form. This will be beta 2 hat xi yi minus beta 2 hat whole square summation, no summation, xi square. Okay. Now I know that if this is the equation, I have to actually prove that summation of yi hat ui hat is 0. So I have to take sum on both sides. Let's take sum on both sides. So taking summation on both sides. If I take summation on both sides, I will get summation yi ui hat ui hat is equal to sum of this entire thing, which is nothing but beta 2 hat xi yi minus beta 2 hat whole square xi square. Let's open this up. Summation beta 2 hat xi yi minus summation beta 2 hat whole square xi square. Beta 2 hat is a constant. So beta 2 hat square will also be a constant. So instead of this, I'm going to go ahead and say beta 2 hat summation xi yi minus beta 2 hat square summation xi square. Now, I know that beta 2 hat is summation xi yi upon summation xi square. This is from the formula of beta 2 hat. So I'm just going to replace this there in this. So instead of beta 2 hat, if I write this, what will I get? I will get summation xi yi upon summation xi square into summation xi yi minus summation xi yi upon summation xi square whole squared into summation xi square. I'm just replacing instead of this formula. Now certain things can definitely be cancelled out. This would be summation xi yi whole square upon summation xi square minus summation xi yi whole square upon summation xi square squared into summation xi square. So one of this will get cancelled out and I would be left up with summation xi yi whole square upon summation xi square minus summation xi yi whole square upon summation xi square, and this would give me 0. So therefore, we proved that the residuals are in no way related to my predicted values. There is no correlation between my predicted values and the values of the residuals. Let's go to the last property of regression lines. Property number 6. The residuals ui hat are uncorrelated with xi. To prove that the residuals are uncorrelated with xi, I have to prove that summation ui minus u bar xi minus x bar is 0. Or because u bar is anyways 0, I know that there is the average of the error terms is 0. So I have to prove summation ui xi minus x bar is 0. Okay. Or I'll open this up. Summation ui xi minus summation ui x bar is 0. But x bar is a constant. So constant can come out of the summation. Or summation ui xi minus x bar, summation ui is 0. But summation ui is anyways 0. So or summation ui capital xi is 0. If I'm able to prove this, that summation ui xi is 0, actually I will put a hat everywhere on ui because I'm talking about sample. If I'm able to prove this, then I can say that ui hat and xi's are not correlated with each other. So to do that, I am directly going to use my normal equation. So from normal equation 2. And what is this? This is when you differentiated ui hat square with respect to beta 2 hat. What will you get? You will get minus 2 summation yi minus beta 1 hat minus beta 2 hat xi into xi is equal to 0. But I know that yi is nothing but beta 1 hat plus beta 2 hat xi plus ui hat. So ui hat will be nothing but yi minus beta 1 hat minus beta 2 hat xi. So instead of this entire thing, I can actually just write ui hat. So this will be minus 2 summation ui hat xi is 0, which implies summation ui hat xi is 0. So directly by using normal equation 2, I have been able to prove that the error terms are uncorrelated with xi's.